So now that you've worked with the properties of exponents, we are going to now look at the graphs of these polynomial functions. First off, let's talk about what a polynomial function is. A polynomial is just the sum of monomials. So if we were to look at this polynomial function right here, we can see that the polynomial is the sum of each of these monomials. And in the polynomial, the exponents are always whole numbers. So if these exponents are not whole numbers, then it's not a polynomial. Also, the coefficients are real numbers, and the coefficient would be the number in front of your variable. A sub n is the leading coefficient, or the coefficient in front of the highest degree, and a sub 0 in this case is just your constant term. And n is the degree of your polynomial, so the highest exponent would be the degree of your polynomial. And a polynomial is written in standard form if the terms are written in descending order of exponents from left to right. So let's look at some common polynomial functions. If you have a polynomial with degree 0, it is a constant polynomial, and the polynomial itself is just a constant. So in this case, f of x equals 4. The polynomial is just the constant 4. If we have degree of 1, it is a linear function. And if we take a look at our example, we can see that it's linear because this is the equation of a line. So f of x equals 2x plus 3 would be an example of a linear polynomial. Degree 2, which you just got done doing the last chapter, would be a quadratic function. And our example, f of x equals 4x squared minus 3x plus 8, we can see that that is in the quadratic form, and our degree is 2. If our degree is 3, we have a cubic function, which this will be new and we'll be talking about this chapter. And our highest exponent is 3, giving us degree 3, so this is a cubic function. And if we have degree 4, we're looking at something that is quartic. So first thing we're going to do is just identify, is this function a polynomial, yes or no? One way to decide if this is a polynomial is to look at the exponents. Remember, we just talked about if this is a polynomial, all the exponents are whole numbers. So if we look at all the exponents here, we have a 4, a 2, and believe it or not, there's an x to the 0 power hanging out with this constant because we just learned that anything to the 0 power is 1. So we really don't need to write that, but this does have power of 0, and these are all whole numbers. So yes, this is a polynomial, and because the highest exponent is 4, this polynomial has degree 4, which makes it a quartic polynomial. So looking at the second example I have, if we look at the exponents, we run into a problem because we have a 2, here is a 1, but here we have a negative 1, which is not a whole number. Remember, the whole numbers are counting numbers, so 0, 1, 2, 3, 4, so on. So no, this is not a polynomial. So the next thing we're going to do is look at evaluating the polynomials, and there are two different ways you can evaluate polynomials. We have direct substitution and synthetic substitution. So first off, we're just going to look at direct substitution, which you've actually done before. If we're evaluating this polynomial when x equals -2, all you need to do is plug in -2. So we're evaluating this function when x is -2. So wherever you see an x, put in -2. And if you evaluate that, be careful your order of operations. You need to square this -2 first, take this -2 to the 4th power. And when you're all done, you should get an answer of -17. So when x equals -2, the value of your function is -17. The second way we're going to look at to evaluate polynomials is called synthetic substitution, which is a nifty little process that you can break out during get-togethers or parties to impress your friends. The first step is to write the function in standard form, and we have our function down here, what you're going to do is list your coefficients, and you're going to put in zeros for the terms that are missing. So if we're using this function right here, you're just going to list your coefficients. So start out with your coefficient of 2. The next coefficient belongs to the term x cubed, but we don't have an x cubed. So you need to write 0 for that. Any missing terms you put a 0 for. The coefficient of x squared is then -8. Then we have x, which is 5, and your constant of -7. Now what you're going to do is you're going to make this nifty little box thing. And the x value to which you're evaluating this function, we're evaluating when x is -2, you're going to write your x value out here outside the box. And this is how the process goes of synthetic substitution. First, what you're going to do is drop down this first term right there, and you're going to multiply your 2 times your x term, so -2, which brings you -4, and you're going to write that right in the next little spot that's open. Then what you do is this whole time you are adding these two lines. So we're going to add 0 plus -4, which gives us -4. And you just repeat that step over and over. So now you're going to take -4 times your x term, -2, which gives you a positive 8. Add these two, -8 plus 8 gives you 0. Then once again, 0 times -2 gives you 0. Write that term up there. 5 plus 0 is 5, so we have 5. Again, multiply that number times your x term, so 5 times -2 gives you -10. And then the last step, -7 plus -10 gives you -17. So your answer lies in this last number that you got. And what this says is that when x is -2, the value of the function is -17, which should be the same answer we got using direct substitution, which it is. So those are the two ways to evaluate polynomials.